Today, the sky at night comes from the heart of one of the most influential organisations in the history of astronomy, but also one of the most surprising.
Welcome to the Vatican. This is St. Peter's in the heart of the Vatican, the headquarters of the Catholic Church for centuries. When the Pope speaks from the balcony behind me, there'll be up to 500,000 people gathered in the square to hear him.
But the Vatican is so much more than a man and a square. It's a city-state with a population of about 1,000, and it's the centre of a global organisation with over 1 billion followers.
But the headquarters of the Catholic Church also hides a secret. This is home to the Vatican Observatory, and astronomers here have played a major role in science over the centuries.
It's funded to the tune of over $1 million a year, with a dozen priest scientists operating telescopes in Italy and the United States. The Vatican is truly a serious player in the field of astronomy.
Tonight, we're in Italy to explore the rich and varied world of Vatican astronomy.
It's a shame if you're a religious person, but you've closed your eyes to science.
From Galileo to modern cutting-edge science. We'll investigate the priest who revolutionised stellar astronomy.
And unearth new scientific revelations from an old photographic star map. And we'll discover how the Vatican is trying to explain creation itself.
But first, Maggie finds out how one of the world's largest religious organisations got mixed up in astronomy in the first place.
This is the Meridian Hall, in the Tower of the Winds. It's perched above one of the great rooms of the Vatican. With its murals of ancient Romans, the hall looks a bit like a stately home. But unknown to most, back in the 16th century, this room had a very different function, which you can only get an inkling of in the dark. It's all a bit Dan Brown or Raiders of the Lost Ark. This is what it's all about. At noon, a beam of sunlight bursts through that hole at the top of the wall and projects onto the floor. It was cloudy while we were here, but this amateur footage shows the spot on the floor. It tells us something fascinating. This whole room is actually a very accurate sundial. And it was built in 1580 to help resolve something they didn't understand. Significant astronomical events like the solstice and the equinoxes were occurring earlier and earlier in the year. The calendar they'd used for millennia wasn't working. By the 16th century, the calendar was nearly 2 weeks out. The spring equinox was occurring on the 10th of March, rather than around the 21st of March, where it had started. And every year, it was getting more and more out of kilter. It was obvious that the number of days in the calendar year didn't match the passage of the seasons, the true astronomical year. The calendar was out. The question was, how much? So, to illustrate the drift, the Pope built this sundial. Every day at noon, when the sun was at its highest, a spot of light was projected on the floor. As the year progressed, the height of the sun changed, so the position of the spot moved too. Recording this change meant priests could work out exactly where the spot would land at noon on the astronomical equinox. Here. Now, they could compare the astronomical date of the equinox with the calendar date. This enabled them to work out exactly how far the calendar had slipped and exactly how long a year actually was, and finally get the calendar back on track. After 7 years of diligent study, Pope Gregory XIII concluded that the real length of a year was 365.2425 days. And to get the calendar back on track, he took drastic action. He removed 10 days from the calendar. Suddenly, the day after the 4th of October was the 15th of October. He recreated the Gregorian calendar that we use today, and something else too. It signalled a new papal interest in the scientific workings of the stars and the planets, in astronomy. But the Vatican's hope for a fruitful relationship with science was soon to flounder. After the success of Pope Gregory's calendar in 1582, things went horribly wrong. A certain scientist came up with an idea that was so controversial that it shook the Catholic Church for centuries to come. I'm talking, of course, of Galileo Galilei.
Galileo got into trouble by promoting an idea that's utterly commonplace today, that the sun is the centre of the solar system. He did that in books like this one. This is his dialogue on the two chief world systems. Not an original copy, but what the Vatican told us was a modern Latin translation from 1699. Having the sun at the centre of the universe, heliocentrism, actually appeared in the works of Copernicus, a generation before Galileo. And for many years it was uncontroversial, taught even here at the Vatican as a useful mathematical device. But nearly a century later, Galileo found himself in a Vatican court just for defending his beliefs. To discover why, Maggie talked to the director of the Vatican Observatory, Brother Guy Consolmagno, in one of the Vatican's many libraries.
So what was Galileo actually tried for?
Good question. You read the trial, and the only thing they discuss is whether or not he obeyed the injunction he had gotten 20 years earlier to not push the Copernican system, which he obviously was pushing. But he said, if there's any place you want me to change so I don't do that in my book, I'll be free to change it. And they kept saying, no, we have to find you guilty of something. Then they trot out a verdict that has nothing to do with what they talked about, saying, we found you guilty of heresy. And he said, no, you didn't. You haven't found any of... So they change it to, we found you guilty of vehement suspicion of heresy, which is kind of an odd thing to be guilty of.
We've sort of got this old system, but after a while, with with Newton's work, we embraced the new system. We've got evidence now. And so the church embraced the idea.
It did, actually. By the 1750s, only 20 years after Newton's final edition, they said it's okay to teach the Copernican system not just as mathematics, but as a way of explaining the universe. With the one exception that Galileo's book was still on the index where you needed permission to read it. It's just human nature. They didn't want to admit they were wrong.
Yes, and they didn't admit they were wrong for a long time.
Well, about Galileo, they took it off the index in about 1820, and they're kind of embarrassed it was still on by then. Nobody had noticed. The interesting thing that happened in 1992, Pope John Paul II said, let's go back and have the church admit it was wrong, not just in what it said about Galileo, but the very fact that Galileo went on trial. I mean, they got Galileo on a technicality. He really did push the Copernican system the way he'd promised he wasn't going to.
Yes.
And, he was guilty of that. But that's not the point. The point is they shouldn't have tried him for it. And so Pope John Paul II apologized publicly to Galileo for having put him on trial. Naturally, people are going to read that, oh, finally the church accepts the Copernican. No. We've been teaching that for a few hundred years.
Despite the Galileo incident, the Vatican continued its interest in astronomy. And within 100 years, they'd built a new observatory within the Vatican walls, and its reputation soon began to grow. The next crucial part of the story of Vatican astronomy takes place in the 19th century, here at the Church of St. Ignazio in the centre of Rome. It was here that a new way of looking at the universe was developed, and it's one that's still important to astronomy today. This is Father Angelo Secchi, a Jesuit priest and a passionate astronomer. He ran the Vatican Observatory for 30 years, helping turn it into a world-class scientific and astronomical institution. He oversaw its move in 1853 from inside the Vatican walls to a larger facility on the roof of this church. One large enough to house the most modern of telescopes. With his state-of-the-art observatory, he started a new and unique project, and he began to see the stars in a way that no one had ever done before. Secchi's innovation was to organise the stars into groups, and he used their light to classify them. And the secret to Secchi's classification was the development of something called spectroscopy. Spectroscopy was first discovered by Isaac Newton when he observed that a beam of light can be split into a spectrum. But later, scientists noticed that those spectra often contained dark lines. And those lines hold unique information about what the source of the light was made of. Secchi's genius, though, was to use this new tool on the stars. His results showed that each star has a distinctive pattern of lines. And Secchi used these patterns to sort the stars into 4 separate groups. His system inspired the way that we classify the stars today. And we now know that the lines in the spectra that he was seeing identify elements in the stars. That's why this is still such a useful tool. On the roof of Secchi's old observatory, I met Father David Brown, who works with the Vatican's current spectroscopy group at their telescope in Arizona. Oh, wow. This is where Secchi did his spectroscopy. What does modern spectroscopy tell us?
Essentially, the idea is still the same. What has changed would be the technology.
So what does a modern spectrum look like?
This would be an example right over here of a modern spectrum. This right over here would indicate the wavelength. This would be the amount of light at each different wavelength. If you can see right over here, these small dips in the curve, this would indicate the presence of certain elements that are absorbing certain types of wavelength right there.
That's what we sometimes see as these black lines in the rainbow spectrum.
Exactly, exactly.
Yeah, I guess this is labelled as magnesium here, and iron and some
right
other
there.
things.
Yes.
Father Brown and his team use modern spectroscopy to research a strange type of star, which has defied classification.
The middle one right over here is part of what we're doing actually at the observatory, what is known as a Lambda Boo star. These are stars that have a certain dearth of what are known as iron peak elements. So it would be elements right around the mass of an iron atom, so cobalt, nickel, magnesium.
Yeah, and you can see there's my magnesium line has disappeared here almost entirely.
Exactly, and so the work centers on observing these types of stars, and of course asking the question, well, why, if these are generally stars of the same spectral type, why do their spectra differ? One particular hypothesis is that such Lambda Boo stars are able to accrete matter, circumstellar matter.
Just leftover material.
Exactly, onto themselves, and this particular type of matter would be, type of gas would be metal poor. And so that type of gas falling onto the star would serve to dilute the concentration of the
so you sort of temporarily hide the underlying atmosphere.
Exactly, because of that.
Fascinating. The fact you could see that in the spectrum, I think Secchi would have been proud of that.
Oh, very much. You know, he would have been fascinated by something like this, and certainly very happy that his work in many ways has continued at the successor to his observatory.
Secchi's work launched a golden age of Vatican astronomical research. And we're travelling 30 kilometres south of the Vatican to the home of that research. Castel Gandolfo, the Pope's summer palace. Here, Pope Pius XI built a new observatory, free from the glare of Rome. Today, It's where half a dozen pre-scientists live and work, and it's home to 4 telescopes. One of these telescopes was at the heart of what was in its day one of the biggest science projects in the world. A project that would dominate astronomy for over 50 years. The Carte du Ciel, the first photographic map of the whole sky. By the end of the 19th century, astronomers had realised that photographic plates could register thousands of new stars, invisible to the human eye. And they could use them to create a new kind of map of the stars. The Vatican contributed 2,000 plates to the project. They're curated by Father Alessandro Omizzolo. Can you tell me, what was the goal of the project Carte du Ciel?
The goal was double. The first one was to have a photographic map of the whole sky.
The entire sky?
Yes. And this project was proposed to the observatories of the world, and so the Pope decided that the Vatican astronomers should be involved in this scientific enterprise, because the aim of the Vatican Observatory was to do astronomy as the professional astronomers do.
These are some of the plates. Now, what's special about this plate?
This is the first plate.
The first plate taken here?
Not only here, all over the world.
Wow, the first plate for the whole project?
The first plate of the Carte du Ciel project. It was taken August 8, 1891.
The plates revealed a wealth of new stars, previously too faint to see, and incredible details of other objects too, like Halley's Comet. Father Alexander, how many stars appeared on each plate?
With the Carte du Ciel prints, we have magnitudes up to 14th, so perhaps 1,000, but no more.
How many plates were generated across the project?
Every telescope generated 2,000 plates.
That's a lot of data.
Yes, a lot of data.
So how was the data processed?
The data are processed by 3 nuns.
3 nuns?
Yes.
Just 3?
3. So these 3 nuns worked many years to get the position of the stars and also the magnitude of the stars.
In the last few years, scientists have renewed their interest in this data.
4, 3, 2, 1, top, décollage.
The European Space Agency launched the telescopes Hipparcus and Gaia to map the galaxy. Comparing those results to the Carte du Ciel images might reveal how the sky has changed over 100 years.
The Vatican Observatory decided about 20 years ago to digitize every plate. So to preserve the information, but also to offer the possibility to the international community of the astronomers to access to this data, to compare the position of the stars from the Carte du Ciel project with the position of the same star from Hipparcus or Gaia.
I think it's a fantastic project, but really exciting that data gathered 100 years ago is still relevant today and can be compared with data we're getting today and tell us things,
yes.
Tell us new things.
Yes.
So thank you very much. It's a brilliant project.
Thanks for you.
Castel Gandolfo is the largest Vatican territory, larger than its base in Rome and all of its embassies, and it's stunning. Because of its beauty, it's hard for me to imagine that within these walls, cutting-edge physics is actually happening. If there's one scientific problem that you would expect the Catholic Church to be working on, it's the problem of creation, how the universe got started in the first place. And in fact, the details of what we'd call the Big Bang Theory were first worked out by a Belgian Catholic priest called Georges Lemaitre. Father Georges Lemaitre was a contemporary of Einstein's and was one of the first to come up with the vision of the universe that we understand today. He realised that Einstein's theories suggested that the universe could be expanding, an idea spectacularly confirmed in the 1920s through measurements of distant galaxies. But this idea also suggests that if you wind back time, you arrive at a moment when the universe must have been a single point. And that point is what we now call the Big Bang. Today, over 100 years after Lemaitre's work, physicists are trying to understand the very first moment of the universe's life. That moment is known as the Planck era. And it's so strange that during it, the two great theories of physics, quantum mechanics and general relativity, break down. Many scientists, including some here at the Vatican Observatory, are now trying to come up with a new theory that combines the two: quantum gravity. Their approach is controversial because it tweaks the fundamentals of gravity itself. When we say Big Bang, we mean that hot, dense state,
Yes.
and also the moment at the beginning.
Yes.
Yeah. Let's talk about the dense state first.
Yeah.
So what physics is happening? What can we say about the laws that govern the universe right back at the beginning?
This is an hard question still for the physics, theoretical physics today, because we do not know really what happens below the Planck time. The Planck time is a time that is approximately 10 to the minus 43 seconds.
So that's a billionth, and then a few bits more.
What we know is that below this time, the laws of classical physics, I mean classical general relativity, breaks down.
So tell me about your work. What's your approach to try and solve these problems?
Essentially, in this approach to quantum theory of gravity, we tried to unify the classical law of general relativity with the quantum world of the quantum mechanics and quantum field theory, with an approach to quantum gravity that is called asymptotic safety. In this asymptotic safety, you vary the constant, what in general are called the constant that are quantities that in classical law of physics does not vary, like the gravitational constant.
That's the strength of gravity,
The strength of gravity.
Which we assume is the same everywhere in the
everywhere
universe.
in the world and so on. We vary this in such a way that the force could become stronger or weaker.
At that early time.
At early time. In such a way, we can find a modification of these forces that in the quantum regime are a bit different. In such a way, we can find the right theory of quantum gravity. This is the modification.
So the idea is you play with things you would normally leave alone to try and get a theory that works at this early time.
At early time, exactly.
And then I guess you've got to do something to make it work later in the universe.
Yeah.
So it becomes the gravity we see.
You have to be sure that when you come back to the ordinary world, you reget the classical law of physics and the classical physics. Otherwise, this quantum theory does not work.
Thank you very much.
It's thrilling stuff. But, like all the work we've seen being done here at the Vatican Observatory, it does beg a question. Why are they doing it at all? Chris met with the observatory's director, Brother Guy Consolmagno, to talk about the relationship between astronomy and religion.
So, Brother Guy, thank you for having us in this rather wonderful place.
It's great to show it off. I just love it.
Yeah, but I guess my question is, why are you here? Why does the Vatican have astronomers?
Why does anybody have astronomers? You know, a friend of mine says it's because we couldn't afford a particle accelerator. Why does anybody do astronomy? It's not going to make you rich. It's not going to make you famous. It's not going to get you girls. Didn't work for me. So why do we do astronomy? I had no answer for that when I was a postdoc at MIT. And I quit and I joined the Peace Corps and went off to Africa. And the Africans were fascinated with astronomy. The Africans wanted to know, why did we go to the moon? What was it like when we got there? They wanted to look through my telescope, and when they saw the rings of Saturn, they went, wow. And that's when I realized that we don't live by bread alone. Astronomy is one of those places where we can ask bigger questions than just what's for lunch.
I guess people are surprised that somebody of deep religious faith can be a scientist. And I'm trying to think why that is. And here's what I've come up with.
Okay.
I think what it is that in science, it's all about creating simple answers. Right? As a physicist, I'm not allowed to invent 600 reasons why a star is misbehaving or why a planet behaves in a particular way. I have to find the simple answer.
Right.
And you seem to do that and then invent or add God to that. So God is not necessary, I think.
Oh, and that's, of course, a complete misunderstanding, really, of what science is that a lot of people have. I put it a different way. People think there's the big book of science with all the science answers, and the big book of religion with all the religion answers, and oh my gosh, what happens if they don't agree? But science is not the book of answers. It's the conversation that you and I have about the answers, and the conversation can go on forever because we'll never get to the bottom of understanding how those bits fit together. The religion side is not these are the answers, but rather this is how we've experienced God. See if you can find that experience, that same God, when you experience the data.
I want to come back to this idea of sort of questions which are approached philosophically, where the questions don't go away and you sort of gain new insight by thinking about them again and again, versus sort of scientific questions where the idea is to solve that and get a new question, and sort of take the next ticket and keep finding out. How do you decide which question falls in which category? Some are obvious, I want to know what spectrum Sirius has. That's the scientific question. But I want to know why death exists. Isn't there a grey area in the middle?
Absolutely. And that's why it's not a solved problem. That's why it's not something that you can have a computer do for you. You can't work out a calculus of ethics. People tried. It's always a disaster. And you have to remember that religion is not in the business of answering questions. Religion is in the business of suggesting questions. So religion and science are both on this road between truth and understanding, but it's a two-way road. And it's a shame if you only have the one and not the other. It's a shame if you're a religious person, but you've closed your eyes to science, because you've closed your eyes to this incredibly rich way of experiencing the Creator.
Well, I'm glad that we are, and I'm glad that we sorted some of this out. Thank you very much.
I don't think we'll ever sort it out, but we'll have a lot of fun talking about it.
Thank you very much.
However you might feel about the overlap between science and religion, the Vatican Observatory has been a fascinating place to visit.
It's always wonderful getting access to a new observatory, but I found this trip quite surprising. I was surprised at the rich history that the Vatican Observatory has. But you'd think there'd be some conflict between a religious organisation working in science, but I've seen no evidence of that at all, just people really enjoying their work.
And for me, it's been a nice reminder that the quest to understand the universe is something truly international, something everyone can take part in, no matter where they're from.
That's it for tonight, but do join us next month, where we'll be looking to the very edges of the solar system to find out what lurks out there.
And remember to check out the star guide on our website to find out what's happening in the night sky during June.
And don't forget, in the meantime, get outside and get looking up.
Good night.
Do black holes hold the answer to the creation of the universe? Horizon delves into life before the Big Bang on Sunday at midnight. Coming up tonight on BBC4, how our lust for oil and petrochemicals has caused conflict and unrest in the Middle East. Planet Oil, the treasure that conquered the world, next.